Greetings, everyone. So, Dijkstra's algorithm. That's gonna be the quiz number 12. It's a kind of a bit of work, but why? You have a whole day, right? That's not a big deal. And you have to know how to do this, but it's not difficult, right? Okay, so first thing we do is we. Okay, let me perhaps see whether I can use a different paper here. No, how do I do this? No, not this way, this way. Paper. This one. No, that's too small. No, that's what I did. Real one. That's gonna be a little bit. Okay, I'll do this. Okay. Or perhaps just lines. Lines is better. No, I'll take this one. Okay. All right. Sorry. First thing we do is list all the vertices. So we have A, B, C, D, E, F, G, H, I, J, K, L, and M. Right. And so the path has to go from A to M. So I put A on top and M to the bottom. It's not really necessary, but that's better for us to see what we are doing. Okay. So these are the vertices that we're gonna eventually visit. And the first thing we do is, what's the cost? And remember how it goes is you start at A, so that is no cost, but everything else has so far infinite cost. And only when we investigate these various vertices, these nodes, the cost will improve. And also we will keep track of the path that leads to the cheapest road. Okay. Remember what we do always. So I'll write it up each time. Each time it's the same procedure. Pick vertex that is still in play. Let me say that, of lowest cost. Investigate its neighbors. And update the cost if necessary. And the updating cost involves also taking track then not only updating the cost, perhaps I should also there say, as well as the path that leads to that cheapest solution. Okay, so we start with use our colors again. We start with A, and we look at the neighbors of A. There are currently two neighbors of A, and so perhaps B and C. So of course we have not visited them, so this will be upgraded. This will be cost C, and C will have cost 2. So both are coming from A. Okay, good. That takes care of our first A. So let's do it this way. We're done with A, and the other ones, we pick vertex of lowest cost. That's now 2. So we're gonna pick 2. Okay, so this will be C. Sorry, I say 2, but I mean C, of course. Yeah, so this is, let's also make sure that I don't get confused here. And now take all its neighbors that are still in play. There are these 3 neighbors here in play. So that's B, E, and F. Okay. First of all, B. Let's look at B. B has a current cost 6. Now, how do we calculate the new cost? We take the cost of how much does it cost already to get to C, plus the additional cost from C to B. Now that is 3, which is actually better. So I should therefore not that one. Hey, this one. Update it to 5, and that means if I come from C, I get better. So what you need to have here, these numbers always have to go down and down, right? You can always fit better and better roads. Okay, that takes care of B. What about E and F? Well, they're clearly there's nothing to think here. They're gonna be better than infinity. So the current cost is 2 to get to C, and to go from C to E, that's another 2, so that is 4. This is coming from C. And for F, the cost becomes 10. Right? 8 plus the cost at C is 2. All right. That takes care of that. So let's do some bookkeeping. So C is gone. I should make this a little bit less big, right? Can I add this? Okay, I can add this. So I'll make it a little bit less big here. Okay, perhaps we do this with all of them. Okay, so let me do this. Let me first get rid of all the other colors. So we remember it's now C that we have taken care of. So let's see. So C is done. So that's done of C. What is the least expensive at the moment is E. So I'm going to pick E. E, where is E? E, okay, E, what are your neighbors? B is still a neighbor, D is a neighbor, and F are a neighbor. Okay. Oh, sorry, I forgot. I wanted this also to be a neighbor, and this is to be a 9. Okay, I forgot to write that. So, right, so J is also a neighbor. Good. So, okay, let's calculate costs. Well, let's mark him here that we don't. B, D, F, and J. Okay. B. To get from E to B, it costs me, to be in E costs 4, and to add from E to B, it costs 1. That's 5. Well, 5 is what I have, so I'm not going to update. If I don't get better, I'm not going to change. Okay. D. Well, D has not been visited yet, so sure. That cost me now 1. No, to go to E costs 4, and then another additional 2, so that will be 6. And this is coming from E. Okay, that takes care of D. What about F? To go in E, the cost was 4, and to go from E to F is an additional 1, so that's 5. That is clearly better. Okay, so this will come E. Okay, and J, okay, that is definitely better. J is a cost of 9 added to the 4, that is 13. And so this is E. I repeat, it's always, we take always this value, the current value, the orange value if you want, and add the additional cost to go to the neighbor that is given by the weights of the edges. Okay, that takes care of E. So let's get rid of E now. So E, you're done. Okay, so E is done, and then the other ones I'm gonna decolor because otherwise I get confused. Okay, what's the least expensive one left? That's 2. Yeah, 2, that's D. So I'm going to take D here, because it was very cheap to go to D. It's amazingly cheap to go to D. That doesn't sound correct. No, I made a mistake, guys. Oh, that's already bad, right? That was not 2. The cost to go from E to D was 2, but, sorry, this is a mistake, right? Oh. This is 6. It's an additional 2. I'm sorry about that. So if you come from E, the cost at E was 4, and to go from E to D, that's 2. So altogether 6. That was bad. And see, you have to really keep your eye on everything. So what's the cheapest now? Well, B, for instance. So let's take B. So not D, not D. So not D here. Did I take D already? Yeah, not D. Get too much color. Okay. E, there goes D. So B, I said, okay, B. So B. Okay, B. Well, you only have one neighbor, so I'm D. So the only effect you're going to have is on D here. Let's see whether you can make D better. Well, 5 plus an extra 6 is 11. No, you cannot. So that's the end of the story. So B is also taken care of. So let's get it here. So B is done. So B is now also red. Okay. F then. F. F. Where is F? F. Where did F go? Oh, here, F. Okay. So what are the neighbors of F? Oh, a couple of new neighbors, I think. All right. Always interesting to have new neighbors, right? And new things gonna happen. So J is a neighbor, K and G. There's two. Let's do the ones that we have not visited yet. So the cost at F is currently 5. Yes, and to go to G, it costs another 1, so that would be 6, and this is coming from F. Okay. K, let's also look at what happens at K. In K, the cost is at F is 5, and another 5, that's 10. So this is coming from F. And then J, can we do better? Well, it is another, it's also 5 to go from F to J, and F itself is 5, so that, yeah, that becomes better. So 10, and that is so coming from F. Okay, so that was a useful detour, right? Because we got a lot of things improved. So you like the thing improve, right? If things don't improve, it's kind of like, yeah, why am I doing this? But okay, this is how the algorithm works. You cannot skip a beat, otherwise you might get not the optimal solution. Okay, 6, 6, 10, and 10. So I'll pick D. D, okay, D, there we go. H and I are now neighbors. Okay, H and I. Oh, they're both new, so that's gonna be quick. There's no comparison. So D costs 6, and from D to H is 4, so that's gonna be 10. This is coming from D, right? And I, oh, that costs only 1. That's a cheap one. So to go to I, that costs me 7. Okay, that takes care of D. So D is now done. All right, the next one, G. G, 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 where is GG? Here's GG. Okay, so only one neighbor, K. Currently it costs 10 to go to K, but this actually would make it cheaper because it would only now 6 to cost a G plus an additional 3, so that will make it 9. So this is coming from G. Okay. Okay, that's it, right? Yeah, there's nothing else to do. So, okay, when you do this, you're gonna have to be very careful that I see what you're doing, right? I don't know exactly how that will work out, but definitely the table that I need to see should be the same table that I get, because except the only freedom is that you can pick the one of lowest value randomly. Okay, and so if you pick it differently than I pick, that could give to a slightly different table, although the end result will be the same, of course. Okay, let's pick the next cheapest one. There's not only one pick, that has to be I. Where is I? Okay, I. What are your neighbors? H. Oh, and M already. So we're gonna have our first estimate how to get to M. That's good. It might not be the best way, but it already gives us a cost. First for H. Currently it costs 7 to get to I, and this road from I to H costs 2, so that actually will be 9. So that actually makes it better. Okay, and then M, yeah, so 7 plus 3, that is 10. Okay, good, that's taken care of. So H, I, M, H, oops, I is done, I is done. The cheapest is now 9. So H, I'm gonna pick H. H here, and so we have, well, it only has M as a neighbor, so let's see, can I get better? H costs 9, and this road adds another 2 to it, which is 11. That would not make it better, so no, it didn't help me. Okay, so H is now gone. Next cheapest one is K. Okay, K. What is your neighbors? Well, it only has one neighbor, L. Okay, so L. Oh, L, I don't know yet. How cheap is it to get to L? Well, to go to K, sorry, I forgot to mark my K here. To go to K, that is 9, and to go from K to L is 1, so altogether 10. So this is coming from K, right? Yes. Okay, so what do? We're done. Okay, Okay, I have taken care of you. Now I cannot pick M, right? Because that's not going to give me anything. I need to go to, I have to go to M. So I have to pick either J or L. Now, of course, at this point we can stop because every road costs at least something. And so if you're in J and L, the cost is 10. And to get to M is always going to be a little bit more. Okay, so this is now, we have found, oh, and I didn't say where did that come from, and I did this from M. Oh, yeah. This was from, where did that come from, guys? From I, right? Yes, from I. See, you have to always. So if I, let's say, when I was at I was inspecting, that was 7, and then the actual tree that I had here made it 10, and that's why I came from I. From H, if I came from H, that was 9 plus 2 was 11, so that's not, I didn't come from H, I came from I. I can only come from those two. I haven't checked L yet. So, but as I said now, let's just double check, right? If I would check J, what would J do? Let's just quickly do it. Let's work it out. Although, as I said, we could stop. Okay, J has only one neighbor to inspect, and that is, well, it's going to be not better, right? Because 10 plus something is always more than 10. Okay, so, right, so I could have actually already immediately scratched that out. So this is done. And now L. So L has only one more neighbor, but again, it's not going to help me because it's going to make it 17. So also that is done. And so the conclusion is 10, the lowest cost is 10. But now what's the path? And that is very important that you keep track of everything here. So the path is the last one, well, of course, is M. And where does M come from? So let me mark the path, let me do it in blue. So M. I come from I. Okay, so that you put I here. Now you look at I. Where does I come from? I comes from D. Then you look at D. Where does D come from? D comes from E. Where does E come from? E comes from C. Where does C come from? C comes from A. And that is our path. So if we would light the path, that would be from A to C, oops, and then we go to E, and then we go to D, to I, and to M. Now you might have just inspecting this thing on your own without the algorithm, you might get to the same thing, but you see it's not trivial road anymore. It kind of is a little bit detourish, right? But that is, yeah, just the way things are. Okay, so I think doing one is more than enough for you to prepare the quiz. There's homeworks in which I've done one, and the video, the lecture video itself contains 1 or 2, I think at least I did. So you have more than enough examples of how this Dijkstra algorithm works.